It is deeply intuitive to assume that proximity to the sun dictates a world's energy. In this model, moving outward from the light simply means moving into a slower, colder, and eventually static state. This map marks the frost line, a thermal boundary roughly 5 astronomical units from the sun, where volatile gases finally drop below their freezing point and turn into solid ice. For decades, the scientific consensus followed this temperature gradient to a simple conclusion. The outer solar system was a primordial freezer, a graveyard of dead objects left over from the formation of the planets. We have been here before. In 1610, Galileo Galilei used his first telescope to challenge a similarly rigid assumption about our system's center of gravity. By observing 4 moons orbiting Jupiter, he proved that Earth and the Sun were not the only centers of motion in the universe. Today, our latest observations are forcing a second great reassessment. At the absolute coldest edges of our system, we are finding evidence of oceans, chemical cycles, and geothermal activity. If distance from the sun doesn't define a world's activity, then we have to ask, is the outer solar system actually a collection of dynamic laboratories hiding in the dark? The first clues arrived in the late 1970s with the Voyager probes, the mission that gave us our first close look at the moons of the gas giants. Instead of a dead, cratered moon, Voyager found Io violently erupting with hundreds of volcanoes, spewing sulfurous lava miles into space. Just next door, the moon Europa appeared as a fractured shell of ice, hiding a liquid water ocean that contained more volume than all of Earth's seas combined. These worlds are powered by tidal heating. As they orbit, the massive gravity of Jupiter pulls at their interiors, rhythmically squashing and stretching the rock and ice. That constant physical kneading creates immense internal heat through friction, which melts the ice from the inside out. This effectively decouples a moon's geological life from the sun. Gravity, rather than light, becomes the engine for activity. In 2004, the Cassini mission moved further out to Saturn, targeting Titan, a moon wrapped in an atmosphere so thick it remained a mystery for centuries. The Huygens probe descended through the haze and landed on a surface shaped by fluids, recording images of rounded river stones and shorelines in -290-degree temperatures. This is Titan's hydrologic cycle. Too cold for water, liquid methane and ethane take its place, evaporating into clouds and raining into vast lakes. These hydrocarbons are built from complex organics forged in ancient supernovae, making Titan an active site for organic chemistry. Titan proved that weather and chemical complexity can thrive in a deep freeze, defying the assumption that distance equals stasis. Even further out lies the Kuiper Belt. For years, we viewed Pluto, Makemake, and Eris as primordial ice cubes, objects that hadn't changed since the solar nebula collapsed. Hubble began to challenge this by finding complex orbital systems here, such as the moon MK2 orbiting the dwarf planet Makemake. But the real breakthrough came in 2024, when the James Webb Space Telescope performed precise chemical analysis of the frozen surfaces of these distant worlds. Measuring the deuterium to hydrogen ratio in the methane ice, Webb found a signature right in the middle. This moderate ratio is the fingerprint of hydrothermal cooking, proving the methane was recently synthesized in a hot, rocky core and pushed to the surface. Even at the absolute edge of the solar system, the smallest bodies possess warm hearts and active geochemistry. Between tidal forces, chemical cycles, and hydrothermal cores, we now see that the outer solar system is kept alive by a diverse range of internal energy sources. The implications are vast. If liquid water and complex chemistry can exist billions of miles from a star, then the environments capable of supporting life are much more common than we ever imagined. Missions like the Dragonfly rotorcraft will soon head to Titan to study these environments directly, looking for life's building blocks in the methane rain. This profound realization forces us to look differently at the billions of icy worlds scattered across the entire galaxy. The cold dark at the edge of the map is not a graveyard. It is a collection of active worlds that prove the ingredients for life can persist almost anywhere.